This is problem number 5 from section 3.3. It says solve the equation, and they give you a quadratic. Now, we know we can solve quadratics in a few different ways. We can factor them, we can complete the square, we can use a quadratic equation, we can solve using square roots. I usually start with solving using square roots to see if we can do that. I see we have an x squared term, but we have another term that has an x in it. That takes the square roots possibility out. Then I look at factoring. I might be able to factor this, but I have a leading coefficient of 2, and anytime I have a leading coefficient, I usually skip the factoring part. So I'm going to skip completing the square as well and go to the quadratic equation right away. But before we do that, I need to subtract the 7x over. So it's 2x squared minus 7x plus 7 equals 0. I got to get the quadratic and equal to 0 so that we can solve for the zeros. Now I want to bring in our quadratic equation. So the quadratic formula is x equals negative b plus or minus b root b squared minus 4ac over 2a. So I'm going to start with b, which is negative, better say x equals here. So it's negative 7 plus and minus root negative 7 squared minus 4 times a, which is 2, times 7 all over 2 times 2. Now I'm going to use my calculator to do a lot of the math for us, a lot of the work. So let's say that we have, I'm just typing in exactly how it's written inside the radical here, negative 7 squared minus 4 parenthesis 2 parenthesis 7. That's negative 7. So I end up with 7 plus and minus root negative 7 over 4. Now this part right here is actually called what's called the discriminant. All right, and you're going to see that anytime your discriminant is negative, you know that you're going to get complex numbers. So I'm going to write that now as equal to 7 plus and minus. Remember, anytime we have that negative inside there, we're going to say I root whatever that number is. I root 7 over 4. Now I'm going to split it, so it's 7 over 4 plus and minus I root 7 over 4. Last step, I'm going to write that into two different pieces, so 7 over 4 plus I root 7 over 4, or x equals 7 over 4 minus I root 7 over 4. And the reason I'm writing that is I want to make sure that I stay in standard form where I have a real part, 7 over 4, and then the imaginary parts, which one could be plus I root 7 over 4 and one is minus I root 7 over 4. And those are the solutions.